Okay, so last lesson from section 7.3. This is the difference, the sampling distribution for the difference in means. And we're going to use ACT scores. These are not the actual ones. I found as much data as I could, but so ACT scores at Stony Point we know are normally distributed with a mean of 26 and a standard deviation of 3. ACT scores at Cedar Ridge are skewed to the right, the mean of 25 and a standard deviation of 5. So we're randomly going to take 25 students from Stony Point and 30 from Cedar Ridge, and we want to see what the two samples look like. So we've got to examine both samples to see what the shape, the mean, and the standard deviation are. So the shape for Stony Point, it's approximately normal because the population is approximately normal. Okay, that's the reason we can say it's approximately normal. The mean for a sampling distribution is the same as the mean for the population, so that's 26. And finally, the standard deviation for a sampling distribution is found by taking the standard deviation from the population divided by the square root of your sample size. So in this case, 3 divided by the square root of 25, and it is 0.6. So that's Stony Point's information. I want to do the same thing now for the Cedar Ridge information. Cedar Ridge is also approximately normal data, but notice it was skewed to begin with. But the sampling distribution is approximately normal because my sample size was greater than or equal to 30. And that's by the central limit theorem. So two different reasons why these sampling distributions are normal. Second, the mean. Well, the mean of your sampling distribution is the same as the mean of your population. So in this case, it's 25. And finally, the standard deviation for the sampling distribution is found by taking the standard deviation of the population divided by the square root of the sample size. So 5 divided by square root of 30 is 0.91. Now suppose we took a sample of same sample here, and we want to look at the difference in the sample means. So we want to create or describe the sampling distribution of the difference in mean scores. And notice we have to state which one is getting subtracted. So Stony Point minus Cedar Ridge. So as we go to describe this sampling distribution, the mean, we simply take the mean of Stony Point minus the mean of Cedar Ridge. So there we go. The standard deviation, we always add the variances. So the variance of Stony Point is 0.6 squared. The variance from Cedar Ridge is 0.91 squared, and we add them, even though we're subtracting in the distribution. And we get 1.09. The shape is going to be normal or approximately normal because both sampling distributions are approximately normal. And again, you have to check both of them. This big old formula over here is how we actually are finding the standard deviation, but it's easier to do it in little pieces first. So that is the actual value way I found it. Next, let's do some normal calculations here for probability. So calculate the probability that a random sample of 25 Stony Point students has a higher mean ACT score than a random sample of Cedar Ridge students. And again, rather than saying that Stony Point is greater than Cedar Ridge, I'm going to subtract the Cedar Ridge ones over, and I want to say that the difference is greater than 0, which would imply that Stony Point is a larger mean value than Cedar Ridge is. So here's what it looks like. It's a normal. The mean difference is 1, and the standard deviation is 1.09. Draw your little chart, your normal curve, The mean value is 1, and I'm interested in being greater than 0. So anything that's positive is meaning that Stony Point has a higher value. And because I'm shading to the right, remember we're going to have to subtract that probability from 1. So to find my z-score, the observed value I'm looking for is 0 minus 1, which is the difference, the mean difference, and divide by standard deviation, I get negative 0.92. Negative 0.92 gives me a probability of negative 1.788. Subtract that from 1, and we get 0.8212 is the probability that Stony Point scores are higher than ACT than Cedar Ridge's scores for the ACT from a random sample of 30 Cedar Ridge students and 25 Stony Point students. Okay, let's take a look at our learning targets from this very short section. So sampling distributions for the difference of two means. So remember the X bar means that it is from a sampling distribution and I'm subtracting them. So to get the shape, you've got to check both individual sampling distributions and the population can be normal, which would make the sampling distribution normal, or your sample size could be greater than or equal to 30. And by central limit theorem, that makes your sampling distribution normal also. The center is found by taking the population mean minus the population mean from the second population. And the variability is the standard deviation is found by taking the standard deviation from the population, squaring it, divided by n, plus the standard deviation squared of the second population divided by the sample size of your second sample, and all of that's square rooted. But make sure that you are adding those two together, not subtracting them. And finally, to do normal calculations, obviously your mean comes from here, standard deviation, and the z-score, the first part of the z-score, the observed value, is simply the sampling mean from the first sample minus the sampling mean from the second one, subtracting the population mean of the first minus the population mean of the second, divided by standard deviation of the first population squared divided by the sample size, plus standard deviation from the second population squared divided by the size of your second sample. And I know that looks intimidating, but you're just plugging these values in. Okay, so just take a little piece at a time and then put it all together. And as always, go ahead and try to check for understanding yourself. Pause me while you do that, and then come back and we'll go over how to work the problems. Okay, welcome back. Let's take a look. We are comparing cost of living of California and Florida. So these are mean values. They're numbers, they're not proportions. And we're looking at different sample sizes here, 16 residents of California and 9 of Florida. So let's take a look here. What is the shape of the mean cost of living for California minus the mean cost from Florida? Well, it is approximately normal. We have to check both populations, and we are told California is approximately normal and Florida is approximately normal. And because they both are approximately normal, the combination of the difference of them will also be approximately normal. To find the mean and standard deviation, the mean of the difference for our sampling distributions is found by subtracting the mean of the populations. So our mean is 2,300. The standard deviation is found by taking the standard deviation for California squared divided by the sample size from California, plus the standard deviation for Florida squared divided by the sample size from Florida. So we've got 3,200 squared divided by 16 plus 2,700 divided by 9. And that comes out to 1,204 and 16 cents. So this is my standard deviation for the difference in the sampling distribution means, and this is the mean, the center. Okay, so let's do a probability part now. So again, I'm looking to see what is the probability that from these two samples that the California one is less than the cost living expense for Florida. So California minus Florida, we want to see if it's that less than 0, which implies that Florida is more. Okay, there's my normal label. Here's my normal bell curve. And I want to see if it's 0 or less than. So I'm looking for this portion on the left. So I'm not going to have to subtract my probability from 1. And if I put in my values, the difference that I'm looking for is 0 minus the difference between the two, which is 2,300, divided by the standard deviation, which is 1,204 and 16 cents. I get a z-score of negative 1.91, which is a probability of 0.0281. So we have a 0.0281 probability of getting those samples, and that the cost in California is less than the average monthly living cost in Florida. Okay, good job. You are all set to handle homework and any questions from 7.3.